Okay, and on to question 9, which looks like a whole lot of fun. Just because it's a kind of slightly curvy, scary looking diagram. So let's see how this one goes. So we've got a curve, and we've got points A, B, and C that are on this curve, and they've given us the x coordinates for them. So the first thing that I would do straight away is actually add that information to the diagram. So imagine drawing it down there. Add on for yourself an x. Oh, not an x, sorry. Add on the values. That is an x value. But add on the values. So that's the value 1. Add on the value 2 there. And add on the value 5 there. Cool. And because we know the equation of this curve as well, so y equals 8 over x plus 2x, we actually could quickly put onto a diagram for ourselves what the y values are that go with each of those. So when x is 1, y is going to be 10, and when x is 2, y is going to be 8. So I'm just setting that up for myself just so that I can see as much information about the situation as possible, even before I've read what point part 1 is all about. Okay, so the point P is increasing at a constant rate of 0.04 units per second. Okay, so we want to find the rate at which the y coordinate is changing as P passes through point. So let's start off by trying to put some of that information into some statements, right? So first of all, there's this constant rate that the x coordinate is increasing per second. So let's call that dx dt. So this is the rate. I'll put this in words. This is the rate at which x is changing in respect to time. Okay, and they've told us that that's a constant rate of 0.04 units per second. And what they want is the rate at which the y coordinate is changing in respect to time as it passes through A. So they want dy dt. What is that? So you think, oh, okay, so is this one of those related rates of change type things? Oh, you know what? It is. We don't have an expression yet for dy dt, so we need to use another related rate of change that we can combine with this one to get dy dt. And I always recognise this because I start writing it out and then I realise that I'm missing something. And I go back to my diagram and it's like, oh, what else could I use? Well, the only other thing I can use is the equation of this curve, which is y equals 8 over x plus 2x. So I go back here and I write it out. So y equals 8. I'm going to write x to the power of negative 1 because I know I'm going to differentiate this, right? So that makes it easier for myself, plus 2x. And then when I differentiate that to dy dx, I end up with negative 8 x to the negative 2 plus 2. Like that. Cool. And then we think, well, I've got to somehow combine this dy dx with this dx dt to get dy dt. And in this case here, it's quite nice because how they are is how we'll use them. So if I take dy dx and multiply that by dx dt, I will get dy dt because these dx's will cancel out. Okay? So to get dy dt, I multiply dy dx, which is negative 8x to the negative 2 plus 2. I multiply all of that by dx dt, which is 0.04. Okay? And at either stage, you can do this either before or you can do this afterwards. We actually know that we're doing it through A, which is when x is 1. So we can substitute it now, or we can substitute it afterwards. I'm going to substitute it now because I have a feeling it'll make it a little bit easier for myself. So that means I can put 1 in here. And then I can go ahead, oops, that's 0.04, sorry. I can go ahead and work that whole thing out. So 1 to the power of negative 2 is still just 1. So that's negative 8. Negative 8 plus 2 is negative 6. And then negative 6 times 0.04 is negative 0.24, I believe. which is cool. And if you were kind of a little bit not sure whether that makes sense, you can see that the y-coordinate at point A is at least decreasing in terms of dy dx. So it kind of makes sense that it would also have a negative rate in terms of time. Okay, and on to part 2, which is finding the volume of revolution about the x-axis. That looks like fun. So we already know that our x-coordinates are 2 and 5, so that's cool. And we know what y is. Y is 8 over x plus 2x. So when we do our integration and it's around x-axis, it's pi y squared. So the first thing we have to do is work out what y squared is. So y squared is all of this squared. Just be super careful. I said this before, but to make sure that you take all of it, whack it into some brackets, put a squared sign on it, and then remind yourself that when you expand this out, it's x over x plus 2x times x over x plus 2x. So we're going to get 3 terms when we've collected all the like terms together. So we're going to get 64 over x squared. Then we're going to get, what are we going to get? 2 lots of 8 over x times 2x. So 2 lots of 16, so 32. And we're going to get 2x times 2x, so we're going to get 4x squared. Then we're going to set up our integration, so it's going to be pi, we'll leave that for later. It's between 5 and 2, and our y squared, we just worked out, is 64, and at this stage here I'm going to make that x squared x to the power of negative 2, just so it makes it easier to integrate, plus 32 plus 4x squared. So then I whack that into some square brackets, put the 5, 2 there, leave the pi out the front for later, and then let's do our integration. So let's add a power, divide through by that power, so that becomes negative 64. Add a power, well, add, in this case, x, and here add the power and divide through by that power. Cool. So next we're going to substitute in our value for 5 and our value for 2 for x and subtract those away from each other. So if I go through carefully and I substitute in 5 into that expression, I get 4,708 all over 15. And when I go through and substitute 2 into the expression, I get 128 over 3. So if I quickly work those onto my calculator and subtract them from each other, I will get the volume of revolution. And I forgot about my pi, sorry. I should leave my pi out the front. Forgot about the pi. So that's going to be 1,356 over 5. Or I could write that as 1,356 pi all over 3. Cool, I was looking at the assessment schedule and they haven't been as picky about fractions as I have, so they've written it as 271.2. 1,356 divided by 3 is 271.2, and so I guess in that case we're not rounding it, so you could write it as a decimal in that case. So that is the correct answer, so that's exciting, yay.